All right, good morning. This is KAP's recording lesson for Wednesday. This is a warm-up, pause, and play when you're ready. All right, and we think that the answer is B. Very good, okay? And we're talking about trick answers. We think that D could be a possible trick answer, and Divine, repeat what you had just said. They would only look at that first one, and that first one is correct, but we talked about how, especially with CAP students, y'all are like, oh, I'm not answering anymore, that's the number, okay? The rest of it is wrong. What else would have been a trick, Saki?
I think C would have been also a trick,
Mm-hmm.
because like if they didn't read it quite right, then we would have added 10.1 plus 5, no, 0.5, we could have put 10.6.
Yeah, if you have forgotten how to add with decimals, if you did 10.1 plus 5 and you didn't line up your decimals, you got 10.6. And so I think C could have been another trick answer because if you forgot that. And then what's happening in A? What do they do each time? Just say that one. They multiply. Very good. Any questions on that warm up? Okay, are we getting pretty solid? Okay, today's I think one of the last days. Again, it's just really solidifying. Just as a reminder for CAP, we have a quiz on Friday. Stuff that's going to be on there is that percentage change from last week and then this additive multiplicative stuff from this week. If you feel like you're rocking this week, just a reminder, go back to we had a lot of activities that we didn't get to last week. So if you want to go refresh, go back to last week and you'll be good. I think we're doing an activity tomorrow just to get us with the flow of things, but if you are wanting to study. All right, let's go over the homework. We should have that out. I'm going to pause for my activity. Okay, looking at these, you don't need me to explain any of this stuff. So, clarify, did any of the fractions throw us off, but then they got used to it? Okay, we'll put that on. Back side. I will say on number 12, the graph was a little off, like even in ours, in the key, you see we had to go off a little bit. If it might not match exactly, you might not have counted by the same thing that they did, but as long as you found, I would say the table is more important in this case, and then you could have been a little different with your graph. Okay, we good? Alrighty, let's look at this. So guys, honestly, I'm gonna let y'all tell me what to write in these blanks because this is the third day of this stuff. Y'all should know what's happening, right? Yeah. Okay. So in algebraic relationship, whose graph is a line is considered a linear relationship. Good job, Carolyn. And other people, but I know you saw. Okay. Our input value, which is our x, is our which variable? Independent. And our output is our dependent because it depends on what we put into the factory.
Is it factory now?
You could think, I've said that a couple times. It's like a factory. You put something in, something happens, something else comes out.
Yeah.
Okay, so this is sort of a visual if it helps you. Which variable do we typically have as our input? We use the letter X, and out comes our Y. Okay, our rule is what happens to X? What happens? They add, they multiply, they divide, or subtract. Okay? And again, just continuing that practice. Again, the reason why we're spending so much time on this is because we're going to be building off of this too. We want to make sure we have a rock solid foundation. Okay? Write an equation to represent the relationship. So today we're going to be finding the rules. Before, on the last few days, like we've been given the rules, now we're going to practice finding them. And we've practiced it, honestly, but again, just making sure it's good. Write an equation to represent the relationship between the independent and dependent quantities. Now, just a little note, with an equation always has an equal sign. So I don't want to see any of this like plus 9 that we sort of did with like the rules. What are we adding 9 to? When we add 9 to that letter, what do we get? What is it equal to? Okay, so equations have equal signs and they have stuff on both sides. What do y'all see to go from X to Y? What do y'all notice? Just shout it out. Times 9 or plus 8. It could be one or the other, but we need to check with all of them which rule works for every single one. Times 9. So who wants to like guess, try and say it out write that rule or that equation. Yes. Y equals 9x. Very good. Okay, remember you could have it could be 9x equals y. You could switch the sides, but I want y'all to get practice with writing it like that. Okay, without the time symbol. You could put parentheses around the x, but you do not have to since it's a variable and a number. Okay, but you can. Okay, and then of course, as KAP students especially, we always want to check. It helps to put it into your own table sometimes just to check. So this is my rule, 9x. If I put in 1, what's that going to give me? 9. If we did 2, that's going to give me 18, and so on and so forth. Again, I'm not going to spend too much time going through this because this is our third day.
Yeah.
Okay? What would be another key way for me to know that this is multiplicative? Or, sorry, multiplicative. Yes. Make a graph, and it should go through. Very good. Question, or that was the answer? Okay, perfect. Again, with KAP, I'm just going to move on along. Number 2, y'all try it out. Ready, set, go. Alrighty, what did y'all, raise your hand, what rule did you find? Yes, Marcelo. Y equals 16x. Very good. And you can check those points. If I did 16x, I'm just going to plug in a random one. If I did 1, 2, 3, 4, 5. I did 16 times 5. It gives me 80. Okay, it should work for every single point. Right? Let's do that third one. It's a word problem. The average person uses about 12 gallons of water each day for showering. Complete the table to show there's a space right there. There's a lot of errors on this. It's fine. Complete the table to show the relationship between the number of gallons a person uses. So they're using G, and it tells you G is for gallons in D days. Okay? Then determine how many gallons a person uses showering each week. Which is the dependent quantity in this case? Payment. The gallons is the dependent. The number of days is my independent because the amount of water I use depends on the number of days. Okay? Just get practicing in that. It's always good to know how to tell. Okay? So what information did they give us in there? What rule did they tell us in that equation? What rule did they tell us? What rule? Steven, you want to guess it? Yeah, what do you think?
Use about 12 gallons of water.
Very good, 12 gallons per day. And what operation do you think that's going to end up being? Huh? Very good, 12 per day. So what's a way I could write that? No, because we're going to use different letters. Steven, you want to try it?
D.
D times. Very good. So I'm going to write 12D, and that gives me class G. Very good. So I can do it with different letters, but I'm going to do 12 times the number of days, which is D, which gives me that value. Okay? I heard someone say like 12x equals Y. I understand most times, but it tells me in the problem what letters that I can use. So we're going to use that top one. Okay, so let's use that. 12 times 1 is 12 times 2 is
24.
12 times 3,
36. 48.
okay, and then right here, let's take note of that. Okay, notice that it's not a number, it's just a letter. How do I go from D to my answer? How do I go from D to G? I do 12D. Okay, when it just has that variable, it's asking you how you're going to get it. You're going to do 12 times D. Okay. So it also asks to determine how many gallons a person uses showering each week. So if we're looking for 1 week, how many days is that going to be? 7. So I need to do 12 times 7. Math. My answer is 84 gallons. You see? Great. Next page. Okay, so we got our rule given a table. Now we're going to practice given a graph. Oh my gosh, I don't have a table. What do I do? How do I know? I see it's a rule. What do I know already about this rule, just based off that graph?
Linear.
It's linear.
Multiplicative.
It's multiplicative because, okay, so I'm gonna make a little note to myself. Go through the origin, goes through origin, multiplicative. It must be multiplicative. Multiplicative. Oh, that's a long word.
Yeah.
Multiplicative, but we sounded it out. You hear me sound it out with the second grader? Never goes away. All right, but still, I'm given a line. How can I figure out what's happening? We do, unfortunately. How can I figure that out? Miss Lana talked about it yesterday in our warm-up. What's like my comfort thing? I always like to make a table. Great. Okay. How can I make a table? How can I fill this in? Look at the graph. Very good. I already know that it's going to go through the origin. Okay. So we just get some ordered pairs. It's sort of up to you which ordered pairs you use. I like where it crosses over nicely. Sometimes when it's in the middle, like right here, you see right above, what is that, 1.5? I don't like that because that decimal could be a variety of things. I like where it makes nice cross sections. So I'm just going to make a few. So there's one like right here, right? There's one right here. You can see it on yours. My picture up here is a little faded. Okay, I like it there. What? I think there's one right there. Okay. Can we find those ordered pairs? Absolutely. Okay, you might have to look at yours. For this first one, it's over 1 and up. What would that first line, what would this line be? It would be 0.5. So that's going to be 1, comma, 0.5. Okay, for this second dot, I have over 2, up 1. Very good. For the next one, it's over right between 2 and 4, so that's going to be 3, comma, I think it's at 1.5, and then the last one is at 4, comma, 0. Okay, I can take those points and put it over here. Again, I'm not going to put in the origin because I already know it's multiplicative, and that's not going to help me find a rule. Not really. I mean, again, I know it's multiplicative. But I'm going to put in the other points. So I got 1 and 0.5. I got 2 and 1. I got 3, 1.5, and then 4, comma, 2. Okay. You could also put them in this, like the ordered pairs, 0.5, 1, 3, comma, 1.5, and then 4, comma, 2. What we're looking for is that rule. What did they do to X to get on Y? Okay, I notice my number is getting smaller. Michaela, you got it? Divided by 2. What are they dividing by 2? X divided by 2. Okay, so let's test that rule out. She says X divided by 2. Okay, let's plug in a few just to check. 1 divided by 2. Okay, 2 divided by 2. Great. 3 divided by 2. Awesome. Does it work? I love it. So I'm going to write that equation. Again, there's like 4-ish different ways. I think we use the same equation so many times at this point. We could say y is equal to x divided by 2. I could write it as a fraction. I could say y is equal to x over 2. I could also write it as a multiplication problem. Y'all remember? Again, I've done this problem like 3 times now. What was one of those other ways?
2y equal x.
We still want the output to be by itself. So what are they doing to the input? That is technically correct, but we would take off some points for that. How can I write it as a multiplication with x? Ava? Very good. 1/2 of x, or 1/2 is the same thing as 0.5. I did do 0.5x. Okay, just a reminder. Okay, do y'all want to try that next one on your own? Y'all get the flow? Okay, ready, set, go with it on this one. All right, for this one, you might have picked different points than I picked, but it should still get the same rule. Okay, I already noticed, is it going to be additive or multiplicative? Because it does not go through the origin. Okay, great, awesome. So it could be adding or subtracting. Okay, that first order pair, again, sometimes that's gonna throw you off this first order pair. It's okay to skip a point. I'm not going to because I want y'all to get comfortable with it. Okay, the order pair for this one would be what, comma, what?
0,2.
Very good. 0,2 because I did not move left or right. I only moved up. Okay, so that first one is 0,2. That next one is 1, comma, 2, comma,
4,
and 3, comma, 5. Very good. Again, what I'm doing is I'm going to take those ordered pairs and I'm splitting them apart. I don't think I did a good job explaining that. So the 0 is my x and 2 is my y. 1, 3, 2, 4, 3, 5. Okay, now ask yourself, what did they do? What did they do? What did they do? Tanner, what did they do? To what? Very beautiful. X plus 2 is equal to y. Again, you can put y on that other side. Okay, let's of course check. 0 plus 2, yep. 1 plus 2, awesome. 2 plus 2, wow. 3 plus 2, amazing. Okay, nothing crazy. Ooh. Why is Miss Lila oohing? Because it's spicy. Okay, what's different? What do we notice that is the same, but what's different? Okay, Devani, what's something you noticed? It looks different. Carolyn?
It's sideways.
It's like sideways. Like what?
There's
There's what?
negative.
There's negatives. It's quadrant 4. Yeah, okay, so it's a weird picture, okay, because it's taking a picture of this place. This is quadrant 4, okay, that's why it has those negatives, okay? What else do we notice is sort of maybe the same that we have seen before? It starts from the top, and what's at that very tippy top? 0, 0. So it's going through origin, so therefore it's still going to be multiplicative, okay? I still notice that it's multiplicative, but I want to figure out what's different. What else do you see? Okay. So, again, let's see what's going to be the same, but what's different. It is still going to be multiplicative because it goes through that origin, but let's find some points. Okay, is there a point right here? Y'all got to tell me. Again, my lines are a little faded. There's a point there, yes?
Yes.
Okay, is there a point right there? Okay. I'm just going to get a handful. I don't need a ton. Okay, so I'm going to look at my key. Again, on your actual paper, I think you can see the lines a lot is better. Maybe not. Okay, let me fill these in. There should be a line. Ooh, I wonder if we can be fancy about this. Okay, there should be like a line right here. Yeah, and then here, here. Okay, let's pretend they're perfectly aligned.
Don't tell anyone.
Okay. And then there's a line this way. Yes?
It looks like a crystal.
Okay. Awesome. Okay, so let's look at this. So that first order pair is 0, 0. All right, this one is a little faded. I don't know what happened. Okay, for this first point, it's over 1, and then it goes down how many? 2. So the ordered pair for that, again, I went over 1, and then down 2 means my number is going to be -2. Very good. Okay, that's going to be 1, -2. That next one right here, again, let's pretend it's on the line. It went over, how many? It went over 2, and then it went down, let's pretend. It went down how many? 4. Let's see. 1, 2. Someone's talking this out. 2, -4. And then this one is at 3, -6. Very good. Okay, that's what matches my key, so I think those are right. Okay, let's split those ordered pairs, 0, 0, 1, and -2, 2, -4, 3, -6. Now, same process. What did I do to get from X to Y? Anthony, what do you think?
-2x.
-2x. Okay, let's check that. So what -2x? X -2x? Or are you saying -2x? Negative 2x. Let's check that out. Negative 2x. Okay, when they're right next to each other, class, that means to multiply. So let's just solve. Negative 2 times 0. I'm replacing x with that first ordered pair. Oh, we have to remember how to multiply with negatives. There was a cute little thing that Miss Lyle used to tell us. There was a cute little chant. Anyone remember it? Take it away, Tanner. Oh, not right. Okay, okay, class, let's try reading that. Great. So in this case, my signs are different, so negative with it, but it's times 0, so that doesn't help me. Okay, let's go to the next one. Negative 2 times 1. Okay, we still multiply like normal, but signs are different, so negative wins it. Did that work? Yes. Yes, it gave me negative 2. Negative 2 times positive 2. 2 by 2 is still 4, and then signs are different. Negative wins it. Oh, negative 2 times 3. Did that work out? Yeah. Okay. We're bringing back all those good old times. Here they are. Okay, so that equation would be y equals negative 2x. So Anthony, good job. Okay, so let's notice I don't know why this slide. We already said that we noticed that it went through the origin. Great. Okay, that meant it was multiplicative. Is our equation multiplicative? Yeah. Okay, but what did we notice was different about this graph? We noticed that it goes down. Okay, and what do we think maybe caused that thing to go down? It flipped over because that negative made it go down. Okay, that's what caused it. All right, so what's going to happen right now, y'all are going to practice the odds for a little bit. Okay, just working through those odds. See what y'all can do. All right, let me look at the key. Okay, so like number 1, does this match exactly, or do y'all have a little something else on there? No, that matches. Number 1 was y equals 3x, negative 7x. Again, I know you probably didn't get to all of this, but just so y'all can check. Any questions that y'all see that y'all want me to explain? Number 5. Okay, so let's look at number 5. Again, if we're talking, let's please stop that. I understand y'all might be good with this, but other people are not and they can't hear. You'll notice what I did, and someone asked about this, there weren't any points. You sort of have to practice finding your own. Okay, again, like Ms. Lytle said, and you can sort of see, I like to find wherever there's intersection points. So you see how it like crosses over the x and the y. I can see that the 2 lines are crossing over, they're intersecting. Okay, and I'm just going to get my ordered pairs from this. So on this first one, it doesn't go side to side, it's just at 0, and then it goes up 1 and then halfway, so that's 1.5. Okay, this next one, it went over 1 and then up, and it's again halfway between, so that's going to be over 1, comma, 2.5. On the next one, it's 2, comma, 3.5. And so on and so forth. Okay, then you'll see I just wrote those points in a table, and I noticed that it was additive. 1, because it didn't go through the origin, and 2, they just kept adding 1.5 to that equation. And that's how they did that. Okay, again, I wouldn't copy down the answers. I would just do what you can. We are going to do a gym pit, and your homework is going to be the even, and we'll check that tomorrow. Okay, you might still want to keep a piece of paper out for the gym pit, but that is it for the recording.